So yeah, as you said, today I'm going to talk about how we can unlock the potential of silicon nitride photonic integrated circuits by adding active components onto the chip. So I'll just talk a little bit about who we are as a company. So we are a European photonic integrated circuits company with a global outreach. So we're based, as I said, in Europe, and we serve to many countries across the globe. We started here in Switzerland, in Lausanne. This is where our company was founded. We've now grown to have a facility in France, in Corbeil, and now we've just as of last year, we have incorporated in Belgium as well to take advantage of some of the talent that we see coming out of Belgium. We're a company based, well, it says 70 photonic enthusiasts. I think we're now up to 80 photonic enthusiasts. We are all highly trained, highly skilled, and very enthusiastic about working on photonic integrated circuits. So what is it exactly that we do? We have the best-in-class integrated passive silicon nitride. So we have incredibly low loss silicon nitride. We have 3 different technologies, which I'll talk about briefly, and an extensive PDK, so you can use our chips and our design services. So we have 2 fabrication lines where you can fabricate your photonic integrated circuits. We have one which is for our standard technology. So here we have a number of different technologies installed. And these can be used to do very high volume manufacturing. We also use it for doing pilot line studies and niche quantities. And we have an offering where you can join a multi-project wafer run so that you can take advantage of this standardized industrialized process, but with a lower cost and a lower entry barrier. So that's one platform, and the other one we have is our R&D line. So here, if you need something specialized, if you need something away from the standard, then it's possible to use our R&D line to look at new concepts, to understand new technologies and new materials. And the benefit here is once we've developed something on our R&D line, we can then transfer it to the 200mm line, where we're able to offer, again, higher volume and a very standardized process. So silicon nitride is a very nice platform for photonic integrated circuits because you can work at a lot of different wavelengths. It's transparent anywhere from 400 nanometers up to 3 or 4 micron. It's high power handling, and it can be very low loss. So what we offer on our standard platform is 3 different thicknesses, and these are aimed at different wavelengths. So with your 800 nanometer platform, we predominantly aim at the C band and for doing nonlinear photonics. For the 350, this is aimed at the C band and the O band, so 1310 nanometers up to 1550. And here we have incredibly low loss. So this is a platform that is optimized for linear passive circuitry. And then we have the AN 150, so the 150 nano platform. And this is aimed at visible light applications. And with each of these processes, we then add on additional modules. So you have your silicon nitride waveguide, where your light is guided through this material. We can then heat the waveguide to change the phase, or we can open the cladding if you want to have a different material integrated onto the waveguide. And we can do a partial etch of the waveguide, so you have polarization control. So now we have these thicknesses, we have these modules, and then to use this, we have an extensive PDK, which includes splitters, combiners, edge couplers. Everything has been tested over many runs using wafer level testing to ensure long-term stability and reproducibility of the circuit itself. So this is a very nice platform. It's existed for a very long time. But the problem with silicon nitride is you can't do fast modulation, you can't do detection, and you can't do amplification of light. So how are we working to solve these problems? First of all, we are integrating lithium niobate on top of the silicon nitride. So lithium niobate is an emerging technology, which at the moment seems to have a huge amount of energy behind it, because we can see that you can modulate your light up to 100 gigahertz, and this has huge potential in datacom, in telecom, also in space and defense, and RF over fiber technologies. So what we've done is we've integrated this new material onto our standard silicon nitride platform. The benefit here is you're able to take a platform which has been established for many years, which we've worked on to develop a very reproducible and very standard stable platform, and we've added on this emerging technology on top of the silicon nitride to add functionality. So here the benefit is that you now have very high speed modulators which are integrated onto our standard silicon nitride platform. So we take our advanced technology, we add on a new innovation, and this gives us this integrated circuit where you have both materials integrated into one chip. This figure here just shows you how the mode looks when the light is guided by the silicon nitride, but the majority of the mode sits inside the lithium niobate, so you can do very high speed modulation. So what's available, what's on offer from us? So as I said, we have this very stable silicon nitride platform now with high performance electro-optic modulators in a robust, reproducible and reliable PDK. And how can you get access to this? So there's two different ways. One is through dedicated runs. So you can come to us with your design, we can fabricate it for you, and this can start at any time. We also are aware that often a lower price point is needed, and for this reason we have multi-project wafer runs. Here these have fixed deadlines, the next one being the 15th of May, so this is coming up quite soon. If you want to join this run, there is still space available, so please contact us. And the next multi-project wafer run will be in September of this year. Just to look at another integration concept we have. So that was obviously for modulation, but we also have photodiodes integrated onto the same platform. So here you can then, not only can you modulate your light, but you can also detect your light on chip. So in this method, we use micro transfer printing. So we take the photodiode from a wafer and we print it onto the waveguide. This has very high alignment accuracy. We can have incredibly high throughput, so you can have many of these PDs put onto your chip, and it reduces the effort required for packaging. This is, again, the benefit of this platform is that we can use our standard silicon nitride and we can add photodiodes on top of the silicon nitride. Again, for key dates, so for dedicated runs, this can start any time, and our next multi-project wafer run is starting in October. So that's all I've got to say. I'll just finish on this slide, just to give an overview of our standard platform and our latest product developments, which include high-speed, high-performance electro-optic modulators and micro-transfer printed photodiodes.